Hello everybody, welcome back. We'll be doing section 2.2 today. Section 2.2, here's the homework assignment. I'm going to read that to you in a second. But I just want to say that I'm trying something new in terms of videotaping, recording. And we'll see if it works. You may not even see this video, I don't know. But we're doing section 2.2. Here's the homework assignment. It's from section 2.2. I didn't even look up the page number because I realized they were downloading and you probably don't have it. Anyway, section 2.2, number 30, 31, 38, 46, 47, 48, 49. And that's it. It shouldn't take you long. Again, you know, my philosophy in homework. Let's keep that just so you know what you're doing. Oh, but again, that's where the quiz and test questions come from. All right, so here's the agenda. The section's called the limit of a function, and we talked a little bit about limits and how important they are in mathematics and calculus in particular. You know, it's the driving force. It's what makes calculus calculus. Is all limits. So we're just going to talk about limits. We'll first use some intuition. I'm going to use 3 examples. Then there's something you do called the table of values where you get your calculator out. We'll do 1 or 2 of them. Limits, pictures of graphs, you can get limits, one-sided limits, 2-sided limits for that matter. Limits are infinite. And when that happens, you'll get a vertical asymptote. And so that's what the agenda is. So let's go. By the way, I know how long I've been. Limit of a function. Consider 3 functions. Let's see, should I put them? Yeah, I'll put them here. F of x equals x squared minus 4. How about that? X minus 2. And f of x equals, let's go, absolute value, x minus 2 over x minus 2. And, oh, I'm sorry, I'm going to name this g. That's g of x. And then h of x, 1 over x minus 2 squared. I just want to consider those. And I'm going to draw pictures of them. Please note, you can't put a 2 into any of those. Remember they told you that a long time ago in Algebra 1, or you can't, even in arithmetic, in 5th grade, you can't divide by 0. And if you put a 2 in here, that's undefined. So let me draw these. This is actually the line x plus 2. That, except there's a hole right there because you can't put a 2 in. That happens to be the point 2, 4. And so we want to keep our eye. So that's what that one looks like. Here, this because the absolute value, if you put a 2 into it, nothing will happen. But if you put a number bigger than 2 into it, it's like x equals 1 or y equals 1. If you put a number smaller than 2 in it, it's negative 1. So that's that graph. And then this graph right here. Oh yes. Whoops. Oh, not at 0. Sorry about that. It's at 2. This graph right here. How to draw? That's a vertical asymptote. We're going to talk about them. Looks like this. Yeah. Oh, that doesn't go below the x's. Yeah. Okay. So those are the 3 graphs in their picture. Now, what we want to do is we want to talk about limits. And we're going to start out with intuition, is why I drew them. And so for these 3 graphs, we're going to suggest the limit as x approaches 2. And so now I'm just going to intuitively discuss this. F at x is, well, let's see. X approaching 2, well, here it's from the negative side. X approaching 2, it's getting closer and closer to that point. Coming from the positive side, x approaching 2 is going this way. It's getting closer and closer to that point. We could actually say the limit as x approaches 2 of that function is 4. And then further, the limit as x approaches 2 of g of x. Well, what's that? Let's see. We're approaching it from this side. That's the positive side. We're going to be doing we're going to put an a with a little plus sign coming from this side. Looks like the limit coming from this side is 1. However, the limit coming from this side is -1. And actually, we would say that this doesn't exist, and we'll talk about that. Again, we're just doing intuition right now. And then, so the limit of the third one, x approaching 2 of, what is it, h of x? Huh. Well, again, if we come from the positive side, it's going way up there. If we come from the negative side, whoop, it's going way up there. What's happening, this denominator is getting really, really small. 2.1, 2.01, 2.0001. That makes that denominator really small. So the whole function goes off to infinity. And we'll talk about that. Yeah, right. When we talk limits to infinity, that's that's when thinking needs to take place. So there's intuition. And this board right here, we're getting to how we're going to express limits. As a matter of fact, let's do this. We say, the limit of a function as x approaches a is L. If and only if, and I shouldn't use such, this is not a proof, this is just an intuition. If and only if, as x approaches a, f at x approaches L. And again, the last section in chapter 2 is a formal definition of limits. So this is just intuition. That's the way we say it. Okay. Let's do this. Okay, so there's something such as a table of values. You kind of get these limits by doing a table of values. It's a problem-solving tool. Problem solving. How to find limits. Well, you can always use a table of values. X, f at x. X, f at x. And I made 2 columns because what we're going to do is if we want to show, we want to find the limit at a determined. And I'll do this in an example in a second. The limit at x equals a. So then what I'm going to do is add a tenth, and then add 100th, and then 100, and then take a and add, I'm sorry, I subtract over here. Yeah, no. And then 0, 0, 1. And then over here I'm going to subtract a minus 0.1, a minus 0.01, a minus 0.001. And what happens is, if you keep putting that stuff in, I'll do an example, sorry about that. If you keep putting it in, if these columns approach something, then you're looking like you're doing a limit. Check this out. Use table values to determine the limit as x approaches 0 of sine of x over x. That's an important one, by the way. This is an important problem. This will show up in, it actually shows up in calculus 2 as well. There's an identity situation going on there. And you take a derivative. Again, it's an important problem. The important function. But right now you don't know, what do I do? So let's do a table of values. So I'm going to do 0.1, 0.01, 0.001, negative 0.1, negative 0.01, negative 0.001. I'm adding, subtracting 0. I'm adding, subtracting from 0. That's where they're coming from. And then I put these values in. Did I write them down? 9983. That's 9983. This is also 9983. This one, 999. Yeah, I remember. 9998, something like that. This is also 9998. This one down here is 9. It's a whole bunch of 9s. By the way, you know how I'm getting these? I forgot to show you. You got to rip out your trusty, dusty calculator and press buttons. This is tedious. But it'll always head you in the right direction. So you can always do a table of values. The point is, these look like headed to 1. And actually the limit is 1, and we're, like I say, we're going to talk about that at length as the semester goes on. So we can extrapolate, we didn't prove anything, but we can theorize, conjecture that the limit as x approaches 0 of sine x over x is 1. We conjecture that. And guess what? This is going to be 2 videos. So we can conjecture that, and here's a picture of it. This is an interesting function. Yeah, kind of looks like the sine, only it oscillates a little bit. And it actually goes under. Does it go under on the other side? I'm not sure. No. Yeah, it wouldn't go under over here. Anyway, so there you go. Oh yeah, well, dots. And the thing is, there's a hole right there, and that's the picture. So the limit from the left side is 1, and the limit from the right side is also 1. So we can make that conjecture, and we will prove that beyond a shadow of a doubt as we go. Oh boy, I'm here. I got another good 10 minutes to go here. Let's stop.